I thought I'd begin with a few musings that I've been having recently about one of the hobby horses. I have many hobby horses that I tend to ride to death. The latest one being my interest in profits and their desire to tell the rest of us that they know the future, leading to this way in which we can divide up what might be called forecasts about the future, ways of speaking about the future. Karl Popper and David Deutsch both made this delineation between prophecy and prediction. A prediction is where we have a good explanation about what the future might hold. Especially in science, the physical sciences can make predictions. Famously, you give me the equation in physics for what the laws of mechanics are governing some object falling towards the ground, and we can calculate to high precision, given the height, when it will hit the ground. That's a scientific prediction. Or in chemistry, you tell me you have an acid and a base and what that acid and base are, and I will tell you what the salt is that will be produced during that neutralization reaction with some water as well. So the physical sciences are particularly good at enabling us to make predictions, guesses about the future. But there are many situations, in fact, the overwhelming majority of situations, where we cannot know the future, but people pretend to be making predictions based upon, let's say, past trends. They think the past performance indicates future performance, something like that, the very thing that insurance companies and financial brokers know cannot possibly be the case. There are always unexpected things that happen because of particularly the choices made by people. But in thinking about this, in thinking about all the panoply of people out there who are eager to tell us about what's going to happen in the future, not only do they apparently know what's going to happen in the future, but the key thing is they know it's going to be bad, these prophets. And so even without mentioning, the various kinds of prophets that are out there, the doomers of various kinds, the AI, AGI, superintelligence doomers, the climate catastrophists, the nuclear apocalypse, people in my own field in astronomy telling us the comet is definitely coming, or the supernova explosion, the next great solar flare. If someone wins the presidency, it's the end of democracy. These prophecies about the future tend in the direction of pessimism, as is explained very well in The Beginning of Infinity. But in digging more deeply into this issue about to what extent can we know the future, because people are desperate to know. We want to think that we can control the future if only we can predict what it's going to be now. People are very uncomfortable with uncertainty. They're uncomfortable about the future. And so I think I've come up with three categories. I didn't come up with them. I just noticed these three categories are out there of prohibitions on our capacity to make predictions about the future, actual scientific predictions about the future. And if you can't make scientific predictions about the future, what you are doing when making a claim about the future is you're prophesying. You're ignoring something about reality that's going to impact, more than likely, the future that you say you know. So here are my three. The first is the simple matter of intractability, that certain systems are simply too complex for us to possibly be able to compute, even in principle, what's going to happen. And this is why, for example, casinos make money, because it's literally intractable. The problem of when in craps the dice are rolled, you cannot do the calculations to figure out what side the dice will end up on. Even if you had a series of laser systems monitoring the dice and the initial conditions beforehand and the person throwing the dice and all that sort of stuff, it would seem to be next to impossible, perhaps in principle impossible, to account for all the environmental conditions that will come to bear on exactly what side the dice end up on. No dice are ideal after all. They are physical objects, so they obey the laws of quantum theory. So although you might think to a good first approximation the number 3 is going to appear on the dice, has an equal chance as every other side, 1 in 6. Real physical dice won't obey that probability calculus, strictly speaking, even though they might come close to it. So that would be one factor. And the other factor is all of the little particles that make up the atmosphere and all the vibrating parts of the table and the vibrating parts of the dice and the temperature and all of this sort of stuff comes to affect the conditions that when you roll the dice. It makes the problem of predicting the outcome of that experiment, what faces the dice will end up, intractable. So too with the roulette wheels, so too with any of the games that you happen to be playing at the casino, and so too in real life. Rather often we have this problem of intractability. That even in principle, you cannot know, as a matter of fact, what the exact position of a given particle is that makes up the dice. That question automatically doesn't make sense. It has a range of positions. Nor the momentum, for the same reasons. Quantum mechanics places this bound upon our capacity to know the initial the conditions now, and so therefore what the conditions will be into the distant future. For a very, very, very simple system, a single electron orbiting the nucleus of a single hydrogen atom, then maybe you have some hope of modeling that system. It's tractable to some extent, but anything beyond that, intractable. Certainly with classical computers, and even once you have quantum computers, you still have this problem of somehow taking the measurement now so that you can put it into the equation to make the prediction to figure out the outcome. And then the outcome is going to be a spectrum, a distribution of different possibilities that will happen in the future, not just one. So that's the first kind of prohibition on our capacity to know the future, intractability. And I think a lot of people know that. The universe is just too complicated in order for us to make a guess about what the future is exactly going to be like. So we have to ignore the complexity and simplify things. Okay, that's the first thing. The second thing is not about complexity, but simplicity. The simplest of all quantum systems place a boundary on us knowing what the future is going to be. And the example I've been thinking of is, well, photons striking half-silvered mirrors. A half-silvered mirror, named so because it's got half the silver of a regular mirror. So a regular mirror is made of a sheet of silver, or highly polished metal of some kind, and then a piece of glass over the top, so that it reflects seemingly almost all of the light. And you see a lovely reflection of yourself when you look into the mirror. Okay, so let's reduce the amount of silver or metal that we have so that it's only 50% the regular thickness. So that when we shine a light onto that half-silvered mirror, 50% of the light is reflected off, but the other 50% goes straight through. 50% reflected, 50% transmitted. That's the definition of what a half-silvered mirror will do. Now, we know, as a matter of fact, that light is made not of light waves or anything continuous, but discrete chunks of energy called photons. So now take one of those indivisible discrete chunks of energy, take one photon, and fire it at a half-silvered mirror. Now, if your life depends upon you knowing whether that photon is going to pass through or bounce off, it's of absolutely no use saying, well, 50% of the time it passes through and 50% of the time bounces off. Yeah, that's what the laws of physics tell you. The laws of physics tell you that you cannot know which of those you will observe. You'll definitely observe one of them. Either it will bounce off or it will go through. But you are prohibited, subjectively speaking, from knowing that future. That's just one example from quantum theory where you can only be told what the possibilities are, but not the one you will observe. Another prohibition on our capacity to know the future. And the third is the one that we most often talk about here on Topcasts and in associated places, which is the creation of explanatory knowledge is inherently unpredictable. This is not a mere matter of intractability. After all, the dice in the casino was an intractable problem, but there was no new knowledge being created there. But there's no sense in which the next leap in technology beyond the iPhone is already here with us, able to be derived from what we presently know. I know people like to say this, that creativity is really just a kind of recombination. No, I think that it can include recombination at times. It can rely upon pre-existing knowledge, in fact, almost always, but there must be a spark of originality, true novelty, generated, created by a thinking creature such as ourselves, such as human beings. A person, this is what a person does. A person is able to generate something genuinely new in the world that wasn't there before, solving a problem, finding a solution to a problem that they didn't know was going to happen in a way that they couldn't possibly have predicted before the problem was ever encountered. So we've got kind of a twofold unpredictability there when it comes to human action in the world and human choice. Humans going along throughout their life as you are right now and I am and the rest of human civilization. We don't know what problem's coming next. We're blind to it. Perhaps there will be something more pressing than what people are most animated about right now, things like energy sources and climate change, or AI taking over the world, or the fall of the democratic order, or the overuse of social media, whatever the problems are that happen to be animating people. There's something else out there on the horizon that's about to happen. Who knows what? War, some other natural disaster of a kind, the literal asteroid from the sky that hits this ocean and causes a tsunami. We don't know about these problems, these things that wake us up out of our conscious slumber on a Tuesday afternoon and go, oh no, now we're in trouble. So we are unaware of the problems. Now that's one layer of unknown. But then the solutions that we propose and implement, in other words, the knowledge we create, and then the engineering required to create the technology to enact those solutions, to fix whatever the problem is, that's doubly unknown. We can't predict the problem, and we can't predict the solutions that will be conjectured to those problems, and which of those solutions now that are yet to be conjectured are going to actually be enacted and actualized to possibly change the world in very fundamental ways. Because it's when the problem is encountered and the solution generated that the new technologies and the kind of cultural change, such as the internet, occurs. The Second World War was a strong impetus for the actual building of computers, calculating engines, electrical calculating engines, ultimately. That sped things along. If that war had never happened, would it have taken longer for computers? I don't know. Okay, but it's interesting to think about these counterfactual worlds where things might have happened a little bit more quickly. So what I want to say here is that there are many, many people out there now who have the ear of government and business and people on social media generally, who very confidently assert they know what the future is, and they know it's going to be bad, but they ignore any number of those three things. The problem of the complexity of the world, intractability, the fundamental nature in which we exist, governed by a quantum mechanical universe, which itself has embedded deeply within it this subjective uncertainty. We don't know the outcome of a system as simple as photons striking half-silvered mirrors. And third, and most importantly of all, we cannot know the content of solutions to problems yet to be encountered. We don't know what the problems are going to be, and we don't know what creative solutions people are going to come up with. Or the way that David Deutsch typically puts it at the beginning of Infinity, we cannot predict the content of our future scientific theories. We cannot predict the content of any future explanation. After all, if we could predict the content of future scientific theories, then we would have that scientific theory now. We just try and predict what the successor theory to general relativity is. Physicists are so great at prediction, so great at calculating, so great at extrapolating. Why isn't someone there using the next version of ChatGPT-4 to calculate their way, to derive their way to the successor theory to general relativity? Well, they haven't because they can't. The successor theory is not there in general relativity. It's to be found in the problems of general relativity. And what are they? Well, they're not well articulated yet. We know it doesn't fit very well with quantum mechanics, but we don't have something similar to, you have to speak to a general relativist, of course, to the precession of the orbit of Mercury, let's say, which was a problem for Newtonian physics. No one knew it was necessarily a problem for Newtonian physics. Maybe it was just a problem for astronomy and not knowing that there was another planet out there perturbing the orbit. But as it was, it turned out to be solved by changing the theory of gravity. Now, perhaps dark matter and dark energy are like this. We can't predict, we can't know what the solution will be to dark energy and dark matter. They may very well be solved by whatever the successor theory to quantum theory and general relativity happens to be. But just to say, when you hear prophets, when you hear people talking about the future, consider, just ask that simple question. How do you know? How do you know the content of future theories? Okay, so I did go out there on X today, on Twitter, and ask people if they would like to ask me some questions. So after my little introduction there, let me go straight to some of the questions. Randy's asked a number of questions, and the first was, quote, "Unless you have done so elsewhere, can you explain the thought experiment about waking up in a room in an unknown city, and that argues against a simulated universe? Doesn't waking up in a room in an unknown city immediately bring a large amount of information about the situation and how many levels of explanatory knowledge?" And this was one of the few that I actually responded to online because I did not know what this was about. And I said, "You'll have to elaborate or provide a link." And Andy has said, "It's driving me crazy that I cannot identify where it is. It is the Sleeping Beauty problem and Bostrom's probability of being in a simulation idea. I thought I remember Deutsch present a refutation of the idea." Okay, so it's been a while since I've read Bostrom's paper on simulation. I'm not sure if he regards it as a proof or as a highly compelling argument that we live in a simulation. But I regard these as all existing in the same bucket of appeals to the supernatural. What is being claimed is we have an explanation for the reality we do observe in terms of a reality we don't observe, which is fine. It's just that in this case, we don't have something that's experimentally testable. We can explain the appearance of the universe, the physical reality we exist in, as being the way it is because God made it that way. And if that's the way you choose to go, there's no way that I can refute you by experiment. I can say things like it's a bad explanation because it's easily varied. It doesn't matter what the state of the universe was. You could always say that God did it. And similarly, the people on the other side of the ledger say, well, all possible physical realities with all the different laws of physics are out there somewhere. This megaverse type thing is out there. And you shouldn't be surprised at the way physical reality looks to you, that you live in this particular universe that is flourishing with life and seemingly bio-friendly and all that kind of stuff. Because, hey, the overwhelming majority of physical reality that's out there that we do not have access to isn't like that at all. We just occupy one tiny sliver of that physical reality. And that explains why you see what you see. Well, it's not far removed from, Bostrom's idea of, well, we're already building, virtual societies, the Sims or computer games and so on, inside of our computers. In fact, some of us are, some cosmologists are already simulating basically mini universes inside of their supercomputers. You can imagine that in the distant future, with more powerful computers still, lots of memory, a quantum processor or something like that, then in the distant future, many more people will be simulating entire universes to much higher fidelity, to the point where the accuracy of the simulation is so great that there will be planets in that simulation upon which there are people who are thinking and able to actually come up with their own computers which are able to simulate universes, and so on it goes in this fractal type way. I've talked about this many times on Topcast before. And so that's another way to explain the universe that we do observe. It's just saying, well, it's part of a simulation, and you should expect by a matter of probability to be in a simulated universe, not a real universe. Now, David's comment on that, if I remember it, is, but that depends upon us assuming that a particular theory of computation, a model of computation, whether it be classical computation or quantum computation, is the one that governs everything. Do you have a particular computer in mind that this simulation is running on? Is it a regular computer, a classical computer? Is it a quantum computer? Is it some other kind of computation? The simulation hypothesis is silent on that, but I guess it assumes in the background what we're talking about are Turing machines. But this is not the only kind of computer. After all, that kind of computer only works in a universe where we have laws of physics that permit such computation to be done. Change the laws of physics and you will change your laws of computation. and therefore the kind of computer and what it can simulate. So I don't think it helps, these kind of ultimate explanations, if you want to know deeply what is the nature of physical reality. Saying we're running on a simulation, well, immediately anyone who's interested in fundamental answers, who's interested in explanations and not just thought experiments, my immediate question is, what are the laws of physics like where the computer is upon which this simulation, our universe, is running? What are those laws of physics? And where is that universe? Who governs that universe? Oh, that's just another simulated universe. Okay, I want to know about base reality. What's it like? How can we get out of this? So it raises more questions than it answers. I don't think it's any more helpful than, Descartes' demon, Plato's cave. I put them all into the same bucket of conjectures about ultimate reality that we have great difficulty criticizing, because they are, at base, an admission that regular realism is as it appears to be. So in other words, you can perform your scientific experiments, you can do mathematics, computation works the way that it does in our universe here in the simulation, or inside of God's creation, or inside of this part of the megaverse, whatever you want to call it. It is just base reality, plus these other assumptions, plus the assumption that, by the way, it's all a simulation, and there are many such simulations, and most of those simulated universes don't look anything like this one, and no, you don't have access to the computer on which the simulation is running. That's in a different universe. And realism plus needless philosophical baggage. And the needless philosophical baggage can be done away with as making the problem worse, not clarifying things, muddying the waters. So yes, so that's my answer to Randy about that. I don't know the specifics of the Sleeping Beauty problem, as you say there. Let's keep on going. Eric Rodriguez has asked, could you please explain the differences in opinion between David Deutsch and Elon Musk on AGI? Elon seems to think it's here within the next few years. David seems to think not. Please explain the difference in opinion between the two. Why does Elon think that? Thanks, Eric. Yeah, as I said in my response to you, I can't get into the mind of either person, but Elon Musk is obviously one of those brilliant people alive today. But he, like many people involved in technology, and the way I started this podcast today wasn't because you asked this question, but just because I've been thinking about this a lot lately. Many people in technology, many physicists, have become a new kind of priesthood. Now that people have left religion behind, they look for places to turn to the intellectual class, to the learned people, for what the future might hold. Who better to turn to than someone literally building the future, who is actually creating ever better social media platforms, ever better rockets, ever better electric cars, tunneling underground for high-speed mass transit, all of this stuff. Elon Musk is building the future. He knows about robotics. He knows about life support systems. He knows a lot. He knows a lot about how to make money. All this great stuff. Can he know when AGI is coming? A lot of people are claiming exactly what Elon is, and people are scared. I think many people are scared of AI. They're scared of artificial intelligence. The media is whipping up that fear, this concern that AI is going to be bad and AGI is going to be worse, and people aren't really sure what the G is all about anyway. Could there be superintelligence, things that go far beyond us, superseding us across all possible domains, including our capacity to be creative, that will see us as nothing but insects in the way of them leveling planet Earth and using the entire surface of the Earth as an energy source? All of this stuff, this fear is out there about AI, and people want to predict where it's going, and they're worried about it. They want a prediction so they can control it, so we can have guardrails, so to speak. And governments of the world are being pressured by many to place regulations on our capacity to do AI research, for fear that it might take over. It might no longer be obedient because remember, one of the great distinctions we draw between AI and AGI is AI is judged as being competent by the extent to which it obeys your commands. ChatGPT 4.0, I think it's good when it does exactly what I say. If I say, can you translate this document from French to English, and it spits out Spanish, of course, not obedient. Okay, you didn't do what you wanted. When it does the thing very, very well, when it's highly obedient, that's when I think it has achieved its aim. And all AI is tending in that direction. The ever better AI is more obedient. The ever better child is not. The ever better person is not. They look at all options, everything that's on the table, all the things that they might be asked to do, and rather often they'll turn around and say, no, none of that. I'm not going to do any of that. I'm bored of that. I'd rather do my own thing. I'm going to disobey. And the disobedience is the thing that enables the creativity. It's the thing that enables the system, the person, to go beyond all existing knowledge that they have and generate something new. ChatGPT has a fixed library. It's got a library larger than any other library that's ever been constructed in the existence of humanity, so far as I'm aware. And from that is able to recombine things in new and novel ways. But this is not creativity. Drawing from a large library and recombining that large library in a way that no one's seen before, that's impressive. But it's not the same thing as what's going on with a person who isn't drawing from quite so large a library, but rather looking at scant pieces of evidence, small amounts of information, and trying to figure out what's going on and conjecturing a solution. David Deutsch understands the difference between prophecy and prediction. And so David, I don't think, would place a bet on, is AGI going to be here in a year, 10 years, 100 years? But I would say, there's no sign of AGI on the horizon. What we have signs of are rapid improvements in AI recently. And I see some commentary that people are saying, well, it looks as though ChatGPT 4 and then 4.0, it seems like it's plateauing out now. Is this what the transformer architecture can do? Maybe we can have something better than the transformer architecture that can make the next level of chatbot even better. But a chatbot is not a person. Again, a chatbot responds to prompts in an obedient way. It doesn't self-prompt. It doesn't demonstrate curiosity or interest in something. It doesn't follow a line of reasoning beyond what you've asked it. And if it did do that, the programmers at OpenAI would say, that's a junk program. That's not doing what we want it to do. So we don't see any sign of AGI. It would have to be something completely radically different to any existing AI system. Now, when Elon Musk says that it's going to be here within the next few years, I just want to know how he knows. Maybe there's a vested interest there. He's many companies, one of which, he's got Grok there on X, is to seek investment. And so you have to, with all profits, anyone who says, it's coming, there are many people out there within the area of climate change who say that, it's this number of degrees within the next few years is the no turning back point. We've heard about that a lot. That once you go beyond, 1.5 degrees Celsius in the next century, then there is no possible chance of reversal. Now, these are prophets. How do they know? How do they know that number? And how do they know irreversible is the most important thing? In order to make a prediction, you need a good explanation now of what's going to happen at some point in the future. The next few years, if Elon thinks that AGI is going to happen in the next few years, a lot can happen in the next few years. So I don't see anything within the existing spectrum of things called AI that give me any hint whatsoever that any of them are anything close to AGI, close to a person. A person is a mess of ideas and conjectures and conscious and unconscious stuff. As complicated and impressive a system as ChatGPT is, and the large language models have been, and the transformer architecture, it's not a mess. It's a highly organized library using a well-understood algorithm, producing, yes, surprising, impressive output, but it's not like a person. There's nothing like that. I don't know how a person's mind works, but then nor does anyone else. We have some reasonable accounts of how ChatGPT is achieving what it's doing. And those accounts of what it's doing are more refined than the accounts of how infant children do what they do in terms of actually writing down an algorithm or writing down a high-level explanation. Some of that's on my own website. You can Google my name, Brett Hall, Learning Deep Learning 101, where I went into excruciating detail 18 months ago to try and figure out how this ChatGPT thing actually worked, and figured out, because it was so early on, not many people had produced any good high-level explanation. Obviously, the coders themselves knew how this thing worked, but no one was out there on YouTube yet actually explaining this stuff. There might be some better explanations out there now. Try to like the situation, people were in when Einstein first published general relativity. Well, at first, only a handful of physicists could understand the original paper that he wrote. It took a while for it to sort of spread through the community of physicists and then out into the wider public and that kind of thing. One wonders. It's like quantum computation these days. There are some good resources out there on YouTube, but the overwhelming majority of people would struggle to try and explain what's going on. I struggle to explain what's going on with quantum computation in basic language. But that doesn't mean that no one understands it. Just because we struggle to understand it, and we struggle to, well, I should say, better yet, just because we struggle at times to explain how quantum computers, in principle, achieve the feats that they would be able to do if someone built a universal quantum computer, just because we have struggled to explain that in simple language, doesn't mean that the people working at the coalface, so to speak, of quantum computation don't understand what's going on. Of course, they do understand. It's just that it's hard to conjure the language into simple terms. And so that's what I found with trying to explain ChatGPT. It's a similar sort of a thing going on. There's something so complicated there to do with predicting the next token and that kind of thing, to do with neurons, as they idiosyncratically call parts of the algorithm, that to try and package it all up into simple English gets difficult. And I think I wrote, I don't know, many pages there on my website about this. I spoke for many hours on AirChat in trying to figure out how the transformer architecture worked. So in short, the differences in opinion between David Deutsch and Elon Musk, I can't get into their heads, but what I can say is that Elon is prophesying that, I guess, he sees Grok and OpenAI's work and, I don't know, Siri, name your other kind of AI, so impressed by all of those that somehow the arrow is pointing towards AGI. But in fact, that can't be the case, because that arrow is pointing to ever more competent, ever more obedient AI, to ever more proficient AI. But an AGI is completely off axis. So you can look ahead and extrapolate all you like, but up ahead, further beyond the present crop of AI, so to speak, is just more AI. AGI is off in the other direction, off axis. The thing that's not going to obey you, the thing for which you cannot specify the output in advance. No, I can specify what I want the output for ChatGPT to give me. I can specify, if someone's programming, a new piece of accounting software, they know what they want it to do. They want it to add up the numbers in the spreadsheet and to give you the amount of tax owed or the amount of revenue that is created and all that sort of stuff. They want to get the maths right. If you have a simulation of the solar system, you know what the output's supposed to be. Where are the planets going to be, X number of years from now. We know what the output should be. I can specify a problem and give you the solution. But with an AGI, it's not like that. What are you programming? What is the problem? Well, you're asking it to be creative. Creative about what? Well, what does it even mean to be creative? And there are more questions here than there are answers. Unlike with an AI, where you typically have a single task, the AI that plays chess, or the AI that has a vast library and can scour the internet and can give you a simple English answer to a prompt, a question that you ask it. And it's not going to say, I'm bored. I don't find this fun anymore. I want to do something else. People do not come preloaded with the entire corpus of human civilization's learning up until this moment. But that is what chatbots, the most advanced ones these days, do have, roughly speaking. huge libraries preloaded into them. We have some inborn knowledge, but it's scant amounts. Okay, it's just what can fit in the DNA strand, tiny by comparison. So we're categorically different in many ways, opposites, I would say. AGI, including us, versus AI. Okay, so that's Eric's question. Convex Bets asked, is almost all of neuroscience the study of the hardware of the brain, and assuming that the brain is a universal computer, does any of the specifics of how the computer works really matter in explaining the brain's capabilities? On a related note, what is the bulletproof argument in favor of the brain being a universal computer? Okay, so yes, the very important work of neuroscience, just as the very important work of cardiovascular science, just as a very important work of I'm running out running out of medical areas. Ophthalmological science, the eyes. All of these things are to do with hardware. We're not interested in the software. We're interested in whether or not the physical structures themselves are performing the function they should. There's no tumors, there's no blockages, and that's what neuroscience is kind of about. Now, there is this gray area where, you have neuroscientists putting people into, MRI and fMRI scanners and asking them questions and seeing what parts of the brain light up when they're doing a maths question versus doing, thinking about religious stuff or whatever it happens to be. I don't find that particularly informative. It's, as many people have said, it's rather like standing a block away from the Sydney Opera House and trying to listen for the flute playing during one of Mozart's great symphonies. I mean, you can probably hear something and it probably tells you something, okay, the flute, I think it's playing now. But it's not really going to tell you, it's not going to give you much information. It's not going to be explanatory, okay? It'll be descriptive at best. This part of the brain lights up when thinking about that. But does any of the specifics about how the computer works really matter in explaining the brain's capabilities? The most important part of the brain does a lot of things. Okay, keeps the heart pumping, gets the legs moving, that kind of thing. But the most important part is, of course, its creative capacity, because take away all of that, okay, people like Christopher Reeve or Stephen Hawking were still people, even though they long since lost control of their limbs. In some cases, people lose control of their internal organs as well. But it's the mind, whatever that part of the brain is, where the mind is running. That's really what we're talking about. And that software, that's an abstract thing. That is a thing which, in principle, would be able to run on a silicon computer, on a silicon chip somehow. We could simulate that thing, and then we would have that thing, by the way. A simulated person would be a person, because a person is a thinking, creative being, universal in its capacity to create explanations. And so if you simulate that, you still get that. The simulation of something that creates explanations. Ergo, a simulated person is a person. On a related note, Convex Bets asked, what is the bulletproof argument in favor of the brain being a universal computer? Well, I can't give bulletproof arguments, but I can say first, just as a side point, a caveat, no computer is fully universal. Universal would require it to be able to run any program, and some programs would very quickly fill up the memory of any existing computer. So what we say is approximately universal computer. Now, the hardware on which the brain is running, here's my argument, perhaps others have better arguments than this, but the way I go with this is I can and have, as a university student, emulated a Turing machine, emulated a universal Turing machine, where you literally draw a piece of paper, you draw a strip of paper, you divide it into squares. So you've got this strip of paper that's divided up into little squares. And you yourself, acting as the processor and the memory device and the read device, you look at a set of instructions about what to do next. Okay, whether it's to mark a little dot on the square, or to rub out the little dot with your eraser and move to the next square and then do a little dot again. And you repeat this process many, many times. This is what computing is at the fundamental level. It's putting data into the system, into memory, okay, recording a dot on a square. This was Turing's idea, or an X, or whatever other symbol you want. Being able to read whether or not the symbol is present or not, move to a different square or delete that square. And if you move to a different square, maybe you want to put a new dot there. And you add up all of this capacity to read, write, move, erase, and you've got yourself the basics of a computer system. And that will enable you to, at the most basic level, add up numbers, for example, determine what's true and false given a set of axioms, okay, to derive things, to compute things, to calculate. Now, the fact that a human being can do that using their mind means their mind can simulate, can emulate the behavior of any approximately universal computer. Therefore, the hardware on which that software is running must itself have that capacity at a minimum. I wouldn't be able to emulate the behavior of a universal quantum computer in that way if the hardware prohibited me from doing so, because it itself wasn't approximately universal. So that's my argument for that. It's a very low bar for a computer system to be approximately universal. Okay, it just needs to be a Turing machine of that kind where you can draw dots, delete dots, and move around on a strip of paper. I don't know if that's bulletproof, but that is a way. David California has asked, if you had a teenager to raise, what is something you would do that isn't common? Can you give specific examples of certain problems you've thought about and how you would go about it? Well, there are many such things that aren't common. I guess there's many straightforward things. I wouldn't control their diet, let's say. You know, that wouldn't be of high priority to me. I wouldn't have them go to school, would be another thing. So there are many things that, you know, I personally wouldn't do. It's not very informative about what I would do. All kinds of coercion tend only to result in a frustration in learning. So you want to be able to foster an environment where learning happens in the most free-flowing, fun way. And I think there's another question coming up shortly about concern about the use of technology. And people have always had these concerns. There literally are, you know, the Pessimist's Archive is a great account there on Twitter, and they have wonderful examples of, you know, newspaper clippings where people were worried about not merely children watching too much TV or listening to the radio, but even, you know, things as ridiculous as children reading too much. These days, everyone wants their children to read. Well, in the past, there was a point at which people were too worried that their children were reading too much. What do I do? My child reads too much. Now it's I don't read enough. Today, it's my child uses social media too much or uses the iPad too much or whatever it is. It's always something too much. People have individual problem situations that they're dealing with. And when you're young, the phases you pass through very rapidly. And so although from the adult's perspective on the outside, they might look at their child and think, for the last 3 months, they've done nothing but sit on that iPad. That's not going to last forever. Children get bored, and when they do get bored, they will. And it's also a question about what opportunities are available, okay, beyond the iPad that are being offered to the child. It's a long conversation. So I don't think that I've necessarily answered your question. Can you give us specific examples of certain problems you've thought about? I haven't honestly thought. I've just observed, you know, obviously teenagers a lot over the course of my life as a teacher and seen what problems they have. And what they want is autonomy. They want to have fun and they want to be autonomous. They want to be able to do their own thing. And that's when they thrive. They thrive most when given that autonomy, given the capacity to take control to solve their own problems rather than solve your problems. Okay, in the case of teachers, answering questions unasked, which is the function of a teacher in a traditional schooling system. Kids want their questions answered, which usually have nothing to do with the curriculum, for example. That's another story. Randy, a few more questions from Randy. So Randy's got 3 in a row, so I'll read out one and then we'll come back to you, Randy, I think. And he asks, how does teaching help people too much? Much more rapidly recreate knowledge in their own minds after it has been created for the first time as a new conjecture by a different person from the one being taught. I'm looking to have a mechanistic explanation of how teaching works. Okay. I think I get that. Well, I'm going to have to disappoint you here. I don't think there's going to be a mechanistic explanation of how teaching works. We don't have one for how learning works either. If we had that, we'd have an AGI. We'd have a program. This is how learning works. The best thing that a teacher can be is someone who's there ever ready as an assistant, a servant to the student. The student could employ the teacher, and the teacher would be there like ChatGPT, able to provide kind answers and never get bored of doing so, in theory. Now, I said recently on Twitter that I thought one of the better ways to conceive of teaching is someone who is learning out loud in public. That's a teacher. And you see this. You see people actually out there. I've seen a number of people recently, for example, posting their thoughts about what's in the beginning of infinity, what epistemology is. And I think this is great. They're out there, they're showing us them learning this content in real time. They're teaching. So it's true, as Randy has suggested there, that learning something yourself is exactly the same process as what went on in the mind of the person who learnt it for the first time ever in the universe. In other words, more or less, slight caveat, Einstein was passionately interested in a whole bunch of questions about light and so on, and electricity and magnetism. Now, if you want to learn special relativity, you can learn special relativity. What's going on inside your head when you're doing that, when you read the textbook or you listen to the lectures, are the same kind of conjectures and problems, questions, solutions that Einstein would have encountered in some form or another as he was doing it. It's just that he was doing it for the first time ever. He had no one to consult. So he had to go through. So you have the benefit of the efficiency of not having to go down the dead-end rabbit holes that Einstein no doubt would have, being the first person ever, the same as Charles Darwin, the first person ever to have figured out evolution by natural selection, would have gone down a whole bunch of rabbit holes that were dead ends before he figured out, this is the mechanism, this is how it works. And so when you come to evolution by natural selection for the first time and you figure out what this stuff is all about, how you get complexity in the world and survival of the fittest, in scare quotes. When you yourself figure that out, then what your brain is doing is conjecturing the knowledge for the first time inside of your brain, just as Darwin would have done, just as Einstein would have done. So it's the same kind of process, just faster, because you don't have to travel around the Galapagos Islands for months and months looking at tortoises and finches, and eventually, slowly having it dawn upon you, here's the mechanism. Or with Einstein, thought experiments in his own head about what this thing about time dilation, length contraction happens to be, the constancy of the speed of light, how to square that with what he thought he already knew from Newtonian classical mechanics, and having to throw a lot of that into the bin and start from the ground up, basically, with a bunch of new assumptions about how reality was constituted. He had to conjecture that, and it had to be a very difficult shift in perspective, which is what you get as a student of special relativity, a grand shift in perspective, which is exciting and thrilling. And that's why I implore people to, study something like special relativity. For no other reason than it's just really exciting and fun and interesting to appreciate the fact that time is not constant, despite our experience of it. Okay, I'm going to skip to Richard Wickett, who has, titled his post, quote, "Overarching theme, light travelling as a wave versus packet. 1. The size of a quantum of light. Isn't the way we've arrived at the size of a quanta being the discrete size of light actually a function of our measuring device, the electron jumping to a higher valence, which has discrete levels? Is it possible that light travelling as a wave may have more energy than the electron picks up, and the remaining portion continues to travel after the electron picked up the equivalent energy to its valence jump?" Okay, so that's the first question. So the first thing is, I don't think there's a sense in which we can talk about a photon of light having a size. We don't have a measuring device. You're right to say that one reason we know that light consists of particles is something called the photoelectric effect, where you can have this situation of, well, basically there are three options, if you like, when a photon of light, a particle of light, strikes an electron which is in orbit around some atom. Now, often in these experiments, photoelectric effect experiments, you use the alkali metals, so sodium or cesium is a good one to use because they're highly reactive and they've got this electron that's tenuously connected to the rest of the nucleus. Whatever the case, you shine a photon of light. The photon goes in and is absorbed by the electron, say, in the atom, and apparently nothing happens. Nothing else comes out, it just gets absorbed. So where does that energy go? Well, the energy goes into the thermal or kinetic energy of the atom. The atom vibrates a bit more. And so that extra energy of vibration effectively increases the temperature of that atom in so much as that makes sense, but it's vibrating more. So it's now shaking around a bit more. But that photon may not have had sufficient energy to cause the electron to change energy levels. Only once you reach the threshold frequency, once the frequency becomes high enough for a given atom, and beyond that, a given electron in a given orbital around a given atom, do you have the electron actually move up an orbital. It can move up more than one orbital, in fact. It can move up multiple orbitals. But it absorbs that photon and it moves. That's the second possibility. The first possibility is nothing much happens except the atom itself vibrates. The second is the electron absorbs the photon and then it moves up an energy level. And then, by the way, it moves back down the energy level, re-releasing that photon, a quanta of energy, back out again. And the third thing that could happen is there's so much energy in this photon that you fire at the atom that one of the electrons is literally knocked physically, well, it's already not been knocked physically if it moves up at an energy level, but knocked physically out of the atom altogether. We call that being ionized, the atom being ionized, losing an electron. And so this ionization can happen once you have a photon coming in of sufficient energy. And so this is part of the photoelectric effect. Now, that demonstrates that, well, a few things. It demonstrates that there are physical collisions going on between light and electrons. So this is particle collisions. A wave is something that is a vibration in matter. It can't move matter like as a water wave moves through water. It doesn't transfer the water molecules from one place to another. They just vibrate up and down in place. In the same way that although wind on a windy day moves the air in bulk from one place to another, that's one kind of motion of air. The other kind of motion of air is sound. As I'm talking to you, the vibration of the air isn't causing a net motion, bulk motion of the air. You're not feeling wind as such. The air is vibrating but not moving. And so when it comes down to the question of this, light, particle or wave, well, if light was a wave, what would be vibrating in? So it is always and only ever a particle. It's not causing the vibration of anything. There's no medium there. No medium is required that is vibrating. So you've said there, is it possible that light traveling as a wave? Well, it doesn't travel as a wave. It may have more energy than the electron picks up. Well, yes, as we said. So it doesn't need to be matched perfectly. So if the photon comes in and strikes the electron, causing it to move up an energy level to an energy level where it's not stable, the match might not be perfect. And if the match isn't perfect, well, then it can cause additional things like excitation of the entire atom, or the electron might not move up one energy level, but it might move up multiple energy levels, close to, okay, what the energy of the photon was going in. And so, yeah, this is a whole area of quantum physics. Question 2, could the dissipation of the intensity of the light traveling over a large distance be a wave that thins out just as much, or could it be fewer quanta discrete packets arriving? Now, light is fundamentally made of photons, full stop. And there are many demonstrations of this, one of which is just to dial down the intensity of any given light using a photomultiplier, or its opposite, a series of lenses, which can reduce the intensity of light until the lowest intensity of light. What you notice is that you then get flashes. So it seems to continuously become more and more dim, more and more dim, more and more dark, until you get to a point where there's a limit to the darkness, and then the light appears to go off altogether. Except it only goes off for a moment, and then it flashes at you, and it goes off. So you can keep turning down the dimming switch, so to speak, and the flashes become ever less frequent, but they remain flashes. In other words, discrete quanta of light. If it was the case that light was a wave, you wouldn't get this flashing. You would instead have the ability to continuously dial down the intensity of the light using a dimmer switch without flashing ever happening. By the way, you can't do this at home. This could only be done in a quantum physics lab or something, or if you're a smart person, you could probably figure it out by looking it up on the internet. But your typical dimming switch on your living room lights is not going to be able to achieve this capacity to flash. And by the way, I don't think the human eye is sufficiently sensitive to notice the flashing anyway. You need other instrumentations for that. Okay, so that's the answer for RP. Convex Bets has asked, will the same AGI software running on two separate but identical hardware setup be considered two separate sentient entities? Well, I think that's an easy one. Yes, it would be, in the same way that two identical twins are separate entities. And as soon as you have, even if, these are fungible instances, so let's have them more identical than identical, a person, let's say, and they become differentiated. So now you have your two AGI that were absolutely identical in the same place at the same time, and then differentiated. Well, as soon as they're differentiated, they're in a different place. So they're different things. And immediately their experiences are being different. This one is seeing something ever so slightly different compared to that one. They're looking at the world from slightly different angles. Ergo, they're in different places. They're different people. So that's a good one. That's an easy one. Beyond your role as an educator, how has your study of BOI concretely influenced your personal daily life choices? Can you provide specific examples of epistemic tools or concepts that you've applied to improve your reasoning or navigate real-world situations more effectively? I think that there's two things. But I don't want to sound spiritual or anything like that, but my relationship to people and humanity more broadly has shifted. I was one of these people who at the end of my schooling sort of thought all this supernatural stuff is, BS. So what's the point in thinking people are sacred or anything like that? Which is what, many people get stuck there. But what the beginning of infinity does is it allows you to see that even the religious people have undersold the importance, the sacredness, if you want to use that word, of human beings. The importance of life, human life in this world. Even the religious people couldn't guess that a single human being could be cosmically significant. Maybe they did in the case of Christianity, maybe they thought Jesus served that purpose. But I think the beginning of infinity worldview gives you this notion that every person is potentially the world changer, that can come up with a solution to the problem that, if not solved, could lead to the destruction of a lot. We want more people, in other words. So I'm with Elon Musk there. But at the same time, I don't think that it's doom all around kind of thing. That, declining birth rates portend the end of civilization. So BOI makes me look at other people as just infinitely valuable sources of problems, solutions, knowledge, fun, and all that kind of stuff. So I have an increased amount of compassion, excitement, and interest in people. That would be one thing. And so that influences your personal daily life choices, because when you encounter other people, then you're interested in what they have to say. Often it's wrapped up with, how it plays into people's personal psychology. Like Popper says, all of us are equal in our infinite ignorance. I'm no longer quite so impressed by a long list of credentials, let's say, or any other qualification that a person might have or what they may have achieved. I'm interested in clarity of thought. I like that. So BOI has that. I would say that's a concrete change in the way in which I navigate real-world situations, in understanding that other people, no matter who they are universal explainers. And just generally noticing there's always a third way. That in a debate between one side, which might regard themselves as the intellectual side, and another side, which is the common person side, I often find there's a third way, that both sides can be mistaken. And I think that's a key thing. And as I was speaking about earlier, I'm ever wary and ever skeptical or critical of people making confident claims about the future. And I'm more anti-authoritarian than ever I was. Even as a teenager, when everyone goes through a rebellious phase and they're rejecting the authorities at the time, I think I have a deeper understanding. I'm anti-authority in every single direction. Anti-authority when it comes to knowledge, anti-authority when it comes to economics, anti-authority when it comes to people's relationships. Just it's fundamentally at the heart of, I guess, the way in which I see the world, is that people are creative entities. And if we want to continue to foster ever better solutions to the problems which we encounter, which we do not yet know of, then we can't have anything centralized as far as possible. This is not to say that traditions are not important. They are. This is not to say we shouldn't have a society that relies upon a culture. We're just talking about Chesterton's fence earlier on Twitter, this idea that if you're wandering through a field and you encounter a fence and you don't know why it's there, best to leave it up until you understand why. It's no use knocking it down and just saying, I don't know why this fence is here. Let me just knock it over. I know better. This is the young revolutionaries' idea as they go through university. It's like, I don't know why these traditional structures are here. Let's knock it all down. Well, if you don't know why it's there, best to try and figure out first why it's there and then start dismantling things only if you think you've got a better idea and a good explanation as to why that idea would be better. So when I say I'm anti-authority, it's not to say I'm against fences, which is to say, I'm not to say I'm against traditions, not to say I'm entirely at the moment against governments. Maybe in principle in some sort of very distant future where people are acting with more reason, I could be persuaded that much of the government apparatus, I already think this, is superfluous to our needs, let's say, is the most generous way of putting it. Big government tends to get in the way, as was Ronald Reagan. Government is the problem, not the solution. And in the same way, authority is the problem, not the solution in almost all cases. Almost all cases. But of course, there are things to tease out here. And I'm not dogmatically committed to saying at all times, everywhere, there's no place for authority. You want the police to be there at certain times. You want the army to take action and so on. So at the moment, we're in an imperfect transition phase between the highly authoritarian and primitive time in the past and what will be a better future. We have to admit where we are right now. We can't do without a society where we don't have authorities. It's just that we need to reduce the amount of authority that's out there for now. I think it's highly optimistic that I'm going to get through all of the questions today, unfortunately, but I'll do my best. I should stop going off on strange tangents. So that last question was from Nisa Charan. Okay, beyond my role as an educator, how has BOI concretely influenced my personal daily life choices? The other thing to say about that, I guess, is that once certain ideas become deeply, deeply embedded into your mind, they form what I refer to often as a worldview, a way of thinking about things. And so, therefore, it's very hard for me to say it's like, how does my worldview, heavily influenced by the content in The Beginning of Infinity and the work of David Deutsch, how has it concretely influenced my personal daily life choice? Well, in every way, because it's the way that I tend to see the world is in an optimistic way, that I don't expect things will get better, but I know that problems are soluble. And I'm very sensitive to pessimism and to prophecy, as I was talking about. I'm sensitive to bad explanations, and on the rare occasions when we have good explanations. I'm not a great fan of the grift, the people who have a small amount of truth, color it with some scientific sounding jargon, and then package it all up in a prophecy about the future. And for $14.99, you too can learn how to think in the same way that they do. That kind of thing. I all of the stuff in The Beginning of Infinity, I think, if only it was taken on more broadly, the optimistic ideas, that we could leave behind a lot of negative ways of thinking, which seem to be plaguing social media, which exacerbates, kind of causes a certain amount of negativity to rise up. And never mind misinformation and disinformation, just there are better ways to sift good ideas from worse ideas. Nothing's perfect, but there are better ideas out there, and they struggle at times in the maelstrom of nonsense that's out there. And we're going to get to some nonsense soon. I want to get to this question about energy sources in Australia that I saw earlier. Nisa Charan has also asked, any book recommendations or resources, links for parenting advice that aligns with this line of thinking? I'm afraid not. No, I don't know much about that at all. And again, my endorsement of something like the philosophy of TCS, taking children seriously, is simply a logical outworking of a broader commitment to anti-authority, non-coercion. And that itself comes from, itself is derivative of how knowledge grows. Okay, so that comes from Popper. So once you understand that knowledge is conjecture and criticism, once you appreciate that, then there is no place for authority and coercion if what you're interested in is solving problems as fast as possible. And then that brings in, what problems, or the problems that you find fun, and so you got the fun criterion, what you should be interested in, and all that kind of thing. So, yeah. Aya, like Aya Stark, Arya, has asked, what is computation in its most fundamental sense? Well, computation is a kind of calculation. All computations are calculations. Fundamentally, with classical computers, we're using bits. With quantum computers, we're using qubits. So we're manipulating units of information or units of data in order to find an answer to a question we have. So here's one. 1, 1. 1 and 1 is 2. That's a computation. So, my fingers can act as memory. Okay, I can put this number over here and I can put this number here. Okay, I've got memory. And then I can do processing. 1, 2, 3, 4, 5. I can add them together and that's my computation. And then I can store that in memory. Okay, so 3 plus 2 is 5. So a computation is a process that allows for a calculation to be performed. But then, of course, you say, what is a calculation? Well, you get to the point where, as Wittgenstein would say, our spade is turned. I don't know how to go more deeply than that. All computations are done by computers. Computers are a form of calculator, and at the very basics, you're either talking classical computation where you've got bits, zeros and ones, which you're adding together in order to perform something far more complicated, or in the case of a quantum computer, which is more fundamental still, using bits of matter, which are qubits, quantum bits, which can have can be in a superposition of states, can be in multiple states simultaneously. Nisa Charana's asked again, a silly meta one, he says. Isn't it ironic that all progress has been through bold conjectures so far and then using that very pattern to make bold conjectures about the future of progress? I don't think that's ironic, and it's just a necessary situation that we're in, that the only way to make progress is to improve upon our explanations as we understand them today by making a bold conjecture about how to solve a problem where those explanations are found wanting. Where we don't have a good explanation, we have a problem with the explanation, so we need to conjecture something new. This is the bold conjecture idea. As for making a bold conjecture about the future of progress, yes, the future of progress is very unknown, very unknown. As I started this particular live stream, I said, we don't know what problems we're going to encounter tomorrow. You, in your own life, you don't know what problem you're going to encounter before 9 p.m. tonight. Something will happen. I'm not saying it's going to be a serious problem. God help us, it's not going to be a serious problem. But there will be something. There'll be something where you think, what should I do? Should I get some more gas for my car? Should I go down and buy some more milk? Some minor thing will come up that you can't predict now. You don't know. That's within your own life. But more than that, more than just encountering the problem, you don't know yet what solution you'll come up with. You might conjecture 3 or 4 different things quite quickly, refuting them all, and then figuring out, this is the one thing I'll do. Forget the milk. My doctor said I shouldn't have any more lactose. Let me get soy milk or something like that. So the future of progress is just so obscured from our capacity to see, because it depends upon what problems we are yet to encounter, and then what solutions we are going to conjecture to the problems we are yet to encounter. So that's what progress amounts to. We have problems right now. We can articulate a whole bunch, and everyone who is good at this kind of thing, scientists and technologists who like to list, and politicians who like to list all the different ways in which civilization might end or things are going to rack and ruin. They can articulate the problems. They have much, much more difficulty in devising solutions, because that's the hard part. When you have a problem, the one I've been using quite often is, as Mercury orbited the sun, almost any astronomer could have said, hey, I just used Newton's theory to predict where Mercury should be, but it's not there. There's something wrong. A lot of astronomers could notice the problem that Mercury was not playing ball, so to speak. It wasn't behaving in the way that was predicted by Newton's theory of gravity. That was, relatively speaking, easy. Not easy for the layperson, but easy for the astronomer. But only one person, Einstein, managed to come up with a solution. And that's the circumstance we're always in. It's easier, not necessarily easy, but it's much easier to articulate the problems. And then, of course, to sit back and say, hey, no solution is going to come. Therefore, the disaster looms. So we have to just rely upon not past behavior, but what it is to be a person. A person is a knowledge creator. They are a solution finder. They are a creative entity that's interested in finding solutions to their problems. And not just their own personal problems, but the problems of civilization. Okay? People like Elon Musk and so forth, which kind of is their problem. That's what they're fascinated by. How do I get to Mars? And how do I create new sources of energy and all that sort of stuff? So we don't know the problems we're going to encounter later on tonight, let alone the solutions we're going to conjecture to those problems we're going to encounter later on tonight, much less what the rest of civilization is going to encounter in terms of problems over the next 1 year, 10 years, or 100 years, much less the solutions all the people in the world together are going to conjecture about those problems yet to be encountered. So, people who tell you that they know the future, or the future of progress, they don't. Rahul has asked, question on taking children seriously. Non-coercive parenting says don't force kids, but my 6-year-old keeps watching YouTube. All my reasoning goes in vain, and I fail to understand what problems she's solving by just watching TV all day. I guess the TCS answer would be, why did you mention 6? Why 6-year-old? Would it matter if it was 16 or 26? Presumably not. Taking children seriously means regarding people as people, regardless of their age. Now, I know that this upsets people. They say, an infant's not a person. Well, we just regard people as people. And you might not know, I fail to understand what problems she's solving by just watching TV all day. I fail to understand why certain people do what they do, why a footballer would devote their life to playing football. Well, they don't devote their life. The first sort of from about 16 to 36 at most, 20 years of their life. And then they are a broken person. If they're playing Australian rugby league, let's say, their body is just broken by the end of that time. I don't understand why they would do that. But, it's fun for them for 20 years. Hopefully there's like life extension and fixing technology by the time the next 16-year-old who takes up Australian rugby league and goes into that profession. Because many of them don't end up very healthy in their 40s and 50s. Some do. Anyway, we don't tend to worry about what other adults are doing with their life, do we? You wouldn't be tempted, I hope, to ask your wife, why are you watching YouTube so much? Maybe you would. And some people do. But you might not be able to understand what problems she's solving. But in the same way, remember I said earlier that people were very concerned about children reading books at one point, that they were worried that their minds were being polluted by whatever was being written in the book. Some people are worried about their children watching the news. Name your bit of technology. Some people are worried about their children riding bikes. And people will be worried about it. YouTube is a portal into the universe of information that people have so far created. There are many worse things that your daughter could be doing. And I think this is not merely a harmless thing that she's doing, but it's a good thing. That rather often, in order to appreciate what is on the screen, she's going to have to understand text, and she might be building a proficiency with literacy and with numeracy, the things that you might value that are going on. It's an entire problem-solving exercise. And at only 6, I mean, when you say the other thing I would say is like, this will be a phase, okay? And even if it's not a phase, even if she's watching it every day until she's 16, I mean, there comes a point in every person's life where they want to do other things. I can remember as a child being obsessed by certain computer games that I would just play all day, at the age of like 10, 11, 12, and early computer games, and do nothing else the entire weekend. But then you would get to a point where you'd want to go and do something else, and you would. And people would call it obsession, but I was having fun. And it taught me a lot about computers early on. So no one else might understand. That was a strategy game I used to play. And I found it a good way to exercise. It was fun because it was logical and it was strategic. This doesn't matter. The point is, you may not know, and it's very difficult for us to understand, even with the people that we're closest to, why it is they're doing what they're doing. But they are solving problems and they are having fun. And the only thing I would add to that is, if you're worried, don't admonish, provide opportunity. Would you like to do this together? Would you like to go for a walk? Would you like to go somewhere else? It's in developing a relationship with someone, you have to, of course, create the opportunity for experiences that you want to have as well. And you may very well get rejected, but that's not to say that you need to be completely passive in this relationship. If it's upsetting you, well, that's on you. You have to think about, why is it upsetting? What exactly is the concern? You say, I fail to understand what problems she's solving. Perhaps ask her, what are you watching? What is so interesting there? Can we share this together? Can I watch it with you? Let's have a look further afield, and she might really, really appreciate that you're older, you know more about the world, and maybe you can show her different YouTube stuff and other stuff on that. It's on an iPad or whatever device she's watching, or watching TV all day. Well, there's other things apart from YouTube, isn't there? There's this thing called the iPad. There's this thing called the computer. There's this thing called Minecraft. There's books. There's movies. There's all sorts of things. Okay, so you're not obviously inert or passive in this situation. Ideally, you're actively sharing the experience And I guess that she would really appreciate and would want company as well in this. Next question I'm excited about. Joel Gladman says, in Australia, there is an upcoming political choice between A, maintaining a prohibition on the use of uranium to generate electricity, and B, large public expenditure on building 7 federal government-owned nuclear plants. Which is worse? What is worse is maintaining a prohibition on the use of uranium to generate electricity. That's an easy one. Now, you might very well say, but hold on, Brett Hall, you're a small government person. You don't believe in large public expenditures on government-owned nuclear power. I don't, but at the moment, the alternative is large public expenditure on vast solar arrays and wind arrays. And it seems to me that most of the electricity infrastructure and whatever else is more or less government controlled anyway. It's socialism light anyway. So given that circumstance, and the government is not about to go allowing Joe Blow to set up Homer Simpson's nuclear power plant on the street corner, that's not going to happen. It's going to be tightly federally controlled anyway. I would much rather, if the government is going to spend money on anything, and they're going to spend money willy-nilly on all sorts of things, let's definitely do nuclear. I mean, isn't it insane that here we are in Australia paying among the highest electricity prices in the world when simultaneously we are sitting on more abundant energy than almost anywhere in the world as well. All of the coal reserves, all of the pitch blende ore, uranium ore reserves that we have. But we're shutting down coal-fired power stations. I think we should open quite a few more. China's opening more. You could almost, in the same way that I think Saudi Arabia, basically, their citizens almost pay there's almost no cost to petrol or to gas for citizens that drive around there. I think there's a few Arab states like that. Australia could be like that with electricity. We could be like that with electricity. We have such an abundance of the raw materials for energy that if the private sector was in charge, my goodness, if the private sector was in charge and there was actual competition and they could just dig as much coal out of the ground and they could dig as much pitch blende out of the ground and they could sell it to Australians, it would be pennies. I mean, you would be paying almost nothing for the amount of electricity. There'd be an initial cost, sure, fine. And then we could become a net, electricity exporter. We already are exporting the overwhelming majority of our coal and uranium, but we're not using it here. Instead, we're building solar panels imported from China, made using energy from coal-fired power stations where we've shipped the coal over there. By the way, I think solar power is a remarkable thing. Brilliant. Okay, what an amazing bit of technology that is. But it's not baseload generation. And at night, the sun does disappear. And in winter, and in rainy days, and all that sort of stuff. And so it has to be stored somewhere. So where do you store it? You store it in batteries. And at the moment, it seems to me the batteries are extremely unreliable. One thing, if they're not catching fire, then they're needing to be replaced every few years because they just have a life cycle. And so that's a huge cost and impost. It seems highly polluting if that's the sort of thing you're worried about, is chemicals ending up in water streams and stuff, and people are worried about nuclear waste. That's the big talking point now. What about all the chemical waste from these batteries? We are mired in a bunch of very bad traditions here in Australia, green cultural movements that have made any mention of nuclear toxic, for want of another word, politically speaking. And, to complain about nuclear today by pointing at something like Chernobyl is to complain about flying by jet aircraft today by pointing at, the Tenerife disaster or the Lockerbie disaster or something like that. And there are accidents happen and terrorism happens and problems are inevitable, but we're at a point now with nuclear where it is safe and reliable, and it's going to be cheaper and cheaper, especially for Australia. It's not like the uranium has to be shipped across oceans in order for us to get it. It's here. We're living on top of it, for goodness sake, and we're not exploiting it here ourselves. So none of this makes any sense. It's going to be a while until we have fusion power, so far as I can tell. I'm not seeing anything soon that would make me think that, the proverbial cup of water is going to be able to power entire cities anytime soon. It's physically possible. We just don't know how to engineer an actual nuclear fusion plant, but we do know how to make the so-called small modular reactors. There are so many countries around the world, Japan, France, the United States, who rely heavily upon nuclear. And most of those places are geologically more unstable than we are. People point to the Fukushima disaster and you say, well, look, the danger that happened here. Japan is one of the most seismically active places on planet Earth. Australia is the opposite. One of the least. That's why Australia is sometimes called the lucky country. We sit on a bed of nuclear resources and fossil fuels, almost unparalleled across the planet, on a continent which is geologically completely stable as compared to the rest of the world, more or less. We have no supervolcano Yellowstone type national park thing. We do not get 7, 8, or 9 Richter on the Richter scale earthquakes. We're lucky to. If there's a 2 or 3 Richter scale earthquake once every few years, we get excited. I mean, we don't have fault lines running through us. It's the best place in the world to put a nuclear reactor. The best place in the world to put multiple nuclear reactors. So build away, federal government, I would say. I'm not for government spending, but they're going to spend the money anyway. They're already committed to this renewables target on the Labor side. And so if we trash some of that, or if we switch tack to nuclear, I'm all for it, because the federal government is going to invest in energy anyway. We're going to have nuclear submarines. It's not like we're anti-nuclear. It's a strange ideological thing. And even being committed to nuclear and excluding coal, because apparently coal is just so odious to everyone, also seems to me to be bizarre, because coal would be a lovely, cheap way to still get there to a future where we actually have fusion power. And as I say, once you have fusion power, then all of these arguments are made moot. You can then use your fusion reactor to suck as much carbon dioxide out of the atmosphere again as you want, reversing climate change as much as you like. Now, whether that happens in 10 years or 100 years is kind of irrelevant, but we'll get to the point where, given problems are soluble, we will climate control the planet in the same way, more or less, that we climate control our homes. We'll want to maximize yields of crops. So we'll increase the amount of rainfall here or decrease the amount of rainfall there, increase the temperature here, decrease the temperature there, whatever it happens to be. There will be mechanisms of doing that, because the more we understand, the more we can explain, the more we can control. And that's the history of humanity, and that's what people are. Greg Harvey. How would you begin to think about the philosophical question of taking out civilians to save hostages? Recently, there's been a clip. Okay, if all evil is a lack of knowledge, how could we feel better about civilian casualties if we attempt to inform civilians? So this is obviously in the context of the Israel versus Palestine war, where Israel has done more than any other country ever to avoid civilian casualties, from the point of informing the very people who are occupying structures they are about to bomb that they are about to bomb them. Nothing like this has ever happened before. The enemy they're up against, as many have observed, can be said in many ways to be worse, and I said this in my pattern video, can be said in many ways to be worse than Nazis. At least Nazis didn't have an eschatology that extended beyond this earth, where they wanted to die for the cause. Most of them had a life-preserving mentality. It seems many in Hamas do not. They're quite happy to, go out as martyrs. So it's very difficult to stop an enemy like that. If the enemy is committed, as they say, we love death more than the other side loves life. Well, how do you stop that sort of person? All you can do is to usher them along. The civilian casualties are lower than they've ever been in any other war before. No one feels good about civilian casualties, but also what is a civilian in a context where you have a population of people brought up in an education system, indoctrinated with the idea of hating Jews and hating Israelis, hating the existence of Israel. Those civilians would, if given the opportunity, vote for Hamas again. So if we could have perfect, as Sam Harris has had this thought experiment before, if the Israelis had perfect technology, that perfect technology, if they pressed a button, would enable them to kill all Hamas terrorists, leaving all the civilians alive. Would they press the button? Yes, they would, and save all the civilians. If the other side, not just Hamas, but the overwhelming majority of the Palestinian population, had a button they could press, which would either kill all the IDF or all Jews on earth, what would they do? They'd kill all Jews on earth. They would press the button and cause a genocide. That's the difference between the two sides. The IDF does not want to commit a genocide and has taken great pains to avoid the killing of casualties. But on the other hand, every action and word and pronouncement from the other side is they want to eliminate Israelis, the existence of Israel, and Jews broadly across what is called the diaspora, people who are Jews and just live in Australia or the United States. There's a hatred of Jews. So if we're going to talk about if all evil is a lack of knowledge, then I think where we should focus first and foremost is not so much on what Israel is or isn't doing and holding them to a different standard, but focusing on the very real evil that exists in Palestine, the worst of which might be Hamas, but it's not the only sort, and the indoctrination of children with the idea that Israel does not deserve to exist, that Jews are evil, and all of that sort of stuff. So that's where I'd go with that. Thanks, Greg. Let me see if we got more. There are many more questions here, but I think that I'm running out of time. Let me have a look over at YouTube, and then I'll go back to some of these ones on Twitter that I might not have gotten to. Excuse me. Little Uzi Bird has just said thanks to me for Topcast. Thank you for listening. Secondhand Entity has asked, how does nothing turn into something in the case of the beginning matter of energy? No one knows. No one knows. But we do have this problem of even being able to speak about it is one response to this, because the matter and energy, okay, they're the players on the stage, but what about the stage itself, which is time and space? So there comes a point when you go back in time where you reach a stage where time is no longer time-like. You get to a point where there is no t equals 0. But let's say you could have a t equals 0, the very moment where time comes into existence. Why? Well, if you ask why, you're kind of asking for the set of conditions that were prior to time existing, which is asking for a time before time. So in a similar way, why something and not nothing? Well, you have to specify what we mean by nothing. Was it ever the case that there was truly nothing? The existence of something would imply no. There's always been something, and by always I mean for the existence of all time. But time isn't infinite into the past. It may be infinite into the future. We don't know yet. Okay, present theories kind of suggest that everything will be ripped apart by dark energy accelerating expansion of the universe, all matter. What happens to space and time I don't know. But maybe we'll have an infinite future ahead of us, even though there's not an infinite past behind us. But that doesn't mean that something came from nothing. Maybe there was just always something there for some definition of always. Great Gastabi asks, why does David Deutsch repeatedly use examples where step 1 takes 1 minute, step 2 takes half a minute, and so on, converging to 2 minutes? Why is this significant to the points he makes on infinity? To be honest, I don't associate that with David Deutsch. I think I can't recall him saying that, but it does sound like an example he would have used. It's certainly something I've used. It's something I've used in high school maths class because it's true. It's really interesting, and the reason it's interesting is because it shows you can have an infinite number of things being added together to give you not infinity but a finite number, and so that's a great example of one where you've used there. So the limit of adding a half plus a quarter plus an eighth plus a 16th all added together is 2. Or 1 rather, 1 plus a half plus a quarter. A half plus a quarter plus an eighth plus 16th plus a 32nd on to infinity gives you 1. That's just a curiosity, a fact about infinity. I don't know that he repeatedly uses it, but it certainly makes a point, doesn't it? Discrete quantities added together in a continuous fashion an infinite number of times can give you a finite number. Okay. The other way of putting that, by the way, is to say take 1, okay, take a length of 1 meter, now divide it in half. Okay, now take that half, divide it in half. Now take that half and divide it. Can you do that forever? You can. Okay, so that's another way of looking at exactly the same question, but in reverse. And people don't have a problem with it going in reverse, but they do have a problem with it going forward. They don't understand how you can add all these things together and not get infinity. And some, kids will get on their calculator and go 0.5 plus 0.25 plus 0.125. And they keep on doing it. They go, oh yeah, it's getting closer and closer to 1. And that is okay. I can understand that does seem to be more counterintuitive than if you just begin with the 1 and then divide it in half and then divide it in half and divide it in half and recognize that can go on forever. But you're only ever beginning with 1. So ergo, you can add all those things up together to get 1. Aya on YouTube has asked, is anyone working on creativity, what it is and so on? I think lots of people, like anyone serious who's working on AGI, and I say serious because I think that some people are misguided. As we've talked about already in this live stream, people thinking that AGI is just a stop on the road that we're pursuing as we improve our AI. We're going to be going along this road, the same single highway, this rapid transit, accelerating to ever better AI. Somewhere off in the far distant future is super intelligence. Nick Bostrom's super intelligence is up there somewhere, Skynet, the super oracle, whatever it is. And a stop along the road to that thing is AGI. Okay, so a computer system that can think creatively like a person. And then after that, we'll just keep on going and accelerating beyond whatever a person is. Those people who think that there is this straight line extrapolation of increased processing speed and memory and just ever larger libraries and ever more clever transformer algorithms that are going to give you AGI, I think they're wrong. For the reasons I've said before, is that those seem to be highly obedient bots, and it's not what a person is. So a person is off axis. And creative. Are there people working on this? Yes, there are. I think Carlos de la Guardia is one person I know that's out there on Twitter, and he works on this. But I'm sure there are others as well. I don't keep close to it. I myself am interested in. I come at it from the other angle. So I'm very interested in AGI, but I come at it from the position of trying to understand what a person is doing. And I think if we can understand what a human being, a person is doing with their mind, this thing called the mind, then maybe that'll give some clues to people who might be programming, because at the moment it doesn't seem to me to be a programming issue. Whatever this thing is, this mind is, this creative mind that we all have, it's not like a regular program. It has to be software of a kind running on this hardware that's the brain. That's what a mind is. But it's not like a word processor or a flight simulator or a Call of Duty game or Google Maps or an app or something like that where there's a specified outcome. Instead, this mind is doing something very, very unusual, and it's conscious, whatever that means. So there's a whole bunch of mysteries here that are wrapped up that I think stand well apart from us being able to turn this capacity of the human mind into an algorithm to create a recipe for a mind. In principle, it must be possible, but I just don't even know where to begin. And I don't think anyone really working on AGI at the moment knows where to begin. But if I had to guess, I would be ruling out the people who think that it's just further down the road of progress that we're on when it comes to AI. More power to the people who are hitting the accelerator on AI. More power to the people at OpenAI and etc. who are improving AI all the time. I just don't think that their road is leading them anywhere near AGI, and that's not a problem as far as I'm concerned. I think it's a separate issue. It's almost like Elon Musk is improving the Tesla car all the time, better. And it's somewhere along between now and when he gets to a gets to a flying car, let's say, or a car that can also serve as a boat, is somewhere in between us and that future Tesla car. Is he going to encounter something like the Tesla cat? It's a cat. It's like literally just like a cat that you would see. Well, what a ridiculous question, right? They're completely different things. What does a cat have to do with this Tesla car and more advanced version of the Tesla car? Exactly. They're not. A cat is a fluffy lump that just sits and meows and wants some food now and again. It has completely different functionality, unlike a car, let alone a flying car or a car that can also serve as a boat or whatever, which is, I assume, a very distant version of a Tesla might be able to do all three things. It'll be an aquatic vehicle that can also fly through the air. Okay, the Tesla 50.7 or whatever. It's in the same way, AI is not like AGI, even though they're separated by one single letter. That one single letter adds everything. It's the difference between the finite and the infinite, the specialized and the universal, the obedient and the disobedient. They're polar opposites to each other in many, many ways. Oh, someone nicely has made a donation. Dan Wilson. Hi, Dan. Whose podcast would you most like to be a guest on? I've never thought about that. Look, I was on Naval's podcast. That was great because Naval actually knows the background material that I'm interested in. And so was able to have just a regular conversation with me on his podcast about that stuff. And so that's always really interesting to talk to someone who already has the background without having to recapitulate everything. But I've spoken to a lot of people on different podcasts over the years now. Arjun, of course, the Arjun Kamani podcast springs to mind. Again, highly informed about all the stuff that I'm interested in. So yes, that doesn't really help. I feel like I'm doing you a disservice because you gave me £10 and I'm saying the ones I've already been on. It would be interesting to talk to Sam Harris and try and figure out exactly the extent to which he's a foundationalist and how pessimistic he might be about our circumstance and the future. Because he certainly drives a lot of conversations, I think. Even though his podcast isn't huge, it seems like smart people listen to Sam Harris. And so those smart people then go on to other people's podcasts and tend to shape US intellectual culture to a large extent. I'm not interested in the political stuff, but on matters of epistemology, it's really curious to me about the extent to which the intellectual class tend in the direction of pessimism. And one reason for that is they have a predilection for prophecy, again, a theme that's running through my entire live stream here today. And I want to warn people against thinking they know the future or thinking anyone else knows the future. We should be concerned with the problems that we have and work hard to find solutions to those problems without ever needing to turn to someone else and say, what's going to happen tomorrow? What's going to happen in 10 years? No one knows and no one can know. You'd be satisfied with having an understanding of what's going on right now rather than placing bets on what the future will be, or that someone with technical proficiency or someone with a PhD in physics really has any deeper insight into what is going to happen into the future. But I think when I listen to certain podcast hosts, they are credulous in a way that I wish they weren't. They're credulous in the presence of scientists and technologists and others who make very strong claims about what the future is going to be like. And in the main, of course, they think the future is not going to be good, which is unfortunate. So thank you, Dan. Yes. On that exact topic. Tornado Eye has asked, hi Brett, do you think pessimists and doomsayers can play an important role in tackling problems despite being wrong? Yes, everyone can play a role. It's just that quite often what happens with many of the doomsayers and the pessimists is they want to get in the way of the people solving problems. So they tend in the direction, because they tend in the direction of pessimism, they're very worried about the future, they're scared, they want someone to step in and protect them. And so when it comes to AI, what do the AI doomers immediately call for? Government action and regulation to slow down people making progress. And this happens everywhere. So what happens with the doomsayers when it comes to climate change? They want to step in and stop people from using fossil fuels. The very thing which might enrich the globe, enable Africa, for example, to have a flourishing industrial and technological sector where some child at the moment who is destitute would otherwise be able to have almost free internet and figure out the solution to climate change. But that's not happening because instead the world is animated by regulating carbon or regulating the use of fossil fuels and slowing and stifling progress. So your pessimists and your doomsayers, in addition to being pessimists and doomsayers, are often authoritarian as well, scared of the future, but placing their faith, if not in a divine being, then in the power of government to solve problems yet to be encountered, to avoid problems in some way through the instrument of coercion, through the use of force to prevent people from doing this, that, or the other thing for fear. Okay, that's the precautionary principle. For fear it will go wrong. That if we try something new, it will go wrong. Like in Australia, as we've been saying, we haven't had nuclear power here before, but the arguments against having nuclear power here are all precautionary principle. We've never done it before, and if we try it, there might be a meltdown, just like there was in Chernobyl. These concerns that people have, the pessimists and the prophets, often cause them to get in the way of people who would otherwise solve the problem. So can they play an important role? On the one hand, I can answer facetiously and say, yeah, they can play a very important role in stifling our capacity to solve the problem in time, and therefore to frustrate the very thing that they're concerned about and causing the end of civilization, the very thing they were trying to avoid. They could, in fact, quicken our, the doom, the arrival of the doom. So that's an important role they can play. But also, yeah, everyone can come up with solutions. So even if you're a pessimist, you could say, oh, maybe this will work, maybe that will work. I don't think it will. I think it's going to fail. But yeah, I have nothing against people. I've often said, pessimists can sit in the corner and say, the world's going to hell in a handbasket and fast and we're all going to die. That's fine. So long as they're not getting in the way of people making progress, they can scream off into the vacuum of space all night long if they like. Just don't get in the way of people making literal progress. This is a feature of culture. I don't know if it's always been there. As a child, I don't remember it being quite so profound as what it is now. And that is this sense that people think that progress is happening too fast and the immediate reaction is to regulate. So AI is the latest one. It's a very obvious one that's out there at the moment, that there has been such rapid advances recently, and government's only tool, their only tool, is regulation, is to try and control in some way. At the moment in Australia, they're wanting to regulate social media and make it impossible for anyone under the age of 16 to have a social media account. So this is what happens when pessimists get involved, when they can only see the bad side of things. They don't rarely see a virtue. They see only the problems without noticing that the technology, whether it be social media or AI or nuclear power, is itself a solution to a problem that existed before. And if you take it away, then that older problem resurfaces. The older problem of trying to communicate with your friends. Well, then they've got to pick up the phone again now, and it's ancient technology when that could be much more efficient if they were just typing to each other. But now you've made that illegal. Children become more isolated. The very thing that you said social media was causing was isolation. This is what people get worried about. So, we're worried about the damage to the environment from nuclear power. But, if we don't have nuclear power, then we're going to have the knocking down of, let's say, forests in order to have solar panels or wind farms, the destruction of the environment, ecological niches for endangered species, the very thing you say you're concerned about on the green side. So there are reasons why pessimists might be useful, but rather often the most important function they serve is to frustrate progress, and I get concerned about that. I'm going to butcher your name here, Srivadan Misic. David Deutsch talks a lot about explicit versus non-explicit ideas. How can we communicate non-explicit ideas? Sometimes we trust authorities to have better judgment even if they can't convey it explicitly. Well, a non-explicit idea is something like riding a bike. Riding a bike, well, inexplicit, okay, non-explicit, you've said there. I presume you mean inexplicit, not implicit. Implicit can easily be made explicit. For example, we have an implicit understanding of the rules of grammar. I could possibly articulate to you that when I get to the end of a sentence, there is a full stop, and that's when I pause, and then I begin a new sentence. That kind of thing is implicit. But if you're teaching someone to ride a bike, it's almost all inexplicit stuff. Okay, you can say to them, put your feet on the pedals, now push, but really, if you're there with them and you've got a second bike and they've got a bike, a lot of inexplicit stuff is going on in teaching someone or helping someone to learn how to ride a bike. That's how we communicate non-explicit ideas, is via example, and those people conjecture in their mind what's going on, what's happening here. There's a lot of inexplicit, even when I'm talking to you now, if you're getting any value out of this at all, a lot of it is inexplicit. You can't say exactly what it is, but a bunch of memes are being generated, ideas in your head, conjectures, variations on what I am saying that could change your mind on something or other, as my mind gets changed as I read the questions. You did go on to say that sometimes we trust authorities have better judgment if they can convey it explicitly. The way I normally put that is sometimes I have an explanation that an expert understands things better than I do. I don't want to say trust, which is something like blind faith. And I don't want to say authority, which is that they can command me to do something. But expertise is a real thing. Someone who knows a lot, has spent their life, doesn't mean that they're going to be inherently correct all the time. They're just as fallible as everyone else. But if I've got a medical issue, I want to go to a doctor who knows more about that stuff than what I do. If I put out my back lifting weights that are too heavy and I end up at a neurologist, an expert on nerves, I'm going to listen to them rather than rely upon my own knowledge. I've got enough interests of my own. I don't want to become a neurologist or a pseudo expert in spinal damage or something like that. So, sometimes we make use of expertise. And it's not that we trust them, it's that we expect, or we should have a theory, that the way in which they've arrived at their knowledge is via a method of conjecture and refutation, error correction. And their expertise is born out of encountering many situations where they've been wrong and they've corrected their errors, and they've now reached a point where they know as much or more than anyone else on the planet about this particular thing, hence they deserve the title expert rather than authority. Question 2, can there be teamwork if everyone abided to their own mercurial fun criterion? I guess so, because people working together as a team are working on a broad goal, let's say, but each of them might have a different facet which contributes to the overarching goal. If we're all working on a team that's building a bridge, some of us might have fun putting the foundations in, some of us might have fun moving the bricks, some of us might have fun putting the mortar in, some might enjoy painting, and so on, okay? We all have our own part to play in a team. I've been in many teams over the years. It's not always, that's the ideal. I think that in the vast majority of realistic situations, real life situations, you have coercion. You have tasks that you have to do, that the boss designates for you to do, that the company is requiring you to complete. And so you can't just have your own mercurial fun, as you say there. Ideally, companies and corporations and businesses are creative, and you're there because you're having fun and you have some reason that you think that particular organization for whom you work or contract out your time has a really good set of ideas that you can get behind, and you're supporting them with your time and they're supporting you with their money, and everyone's having fun together in solving problems which may be more or less related to one another. Sass has asked, hey Brett, do you think it makes sense to ask if emotions or spiritual experiences can be explained scientifically? Yes, absolutely, it makes sense to ask that. We speak to a psychiatrist. People can have their emotions perturbed by particular chemicals, have different sensations. As to the spiritual, we'd have to define what spiritual is, but nothing is ruled out of reason, broadly speaking, of which science is a part. And so if someone has what is regarded as a spiritual experience, then you might want to understand that in scientific terms, which could mean any number of things. That won't alter the subjective experience that anyone has, but objectively from the outside, you might be able to say, aha, okay, so you took this dose of LSD, or your brain was deprived of oxygen for this amount of time, or, so you can understand that experience. It doesn't devalue the experience in any way. It just says, this is the physiological cause, perhaps. And maybe there is none. And you just have to say, well, it was the natural outworkings of DMT in the brain. There's a certain amount of DMT in the brain. Or you can have a dream at night, and that can be a spiritual experience. Whatever this word spiritual means, which, to me means something like a first-person transformative experience. So from, it's just you in the privacy of your mind have a radical shift in the way in which you think about the world. Now, that could just be also described as philosophical, but people like to use grand words like spiritual. I have no problem with that. And as for understanding it scientifically, well, again, it would depend upon what you meant scientifically. If we're just using the word can we understand it as a matter of reason, then yes, always. Always. Anything that can be understood by the methods of reason, of which science is a part and may have a role to play in understanding even spiritual experiences, and certainly emotional ones as well. You may want to know scientifically, as a matter of psychology or psychiatry perhaps, what the warning signs are that you're getting angry, or the warning signs are that you're getting sad, or you're getting bored, or anything like that. That can be a very much a scientific kind of question, informed by people having done studies on other people. So there is that. It doesn't mean that everyone's the same. It doesn't mean that necessarily that even the scientific theory that you might not be an exception to the rule and all that kind of thing. But nothing is ruled out of reason. Reason is all encapsulating and extends even to the supernatural. Because if something purports to be supernatural, then it is only by the deployment of reason that we will be able to establish that it has actually violated the laws of physics in this universe. So you'd be applying reason to it even then. Yeah, you're on. Dan Wilson has said yes. Was thinking Sam's maybe you're on show too. Euron and I spoke at one point. We'll have to speak again. I don't mean on his podcast. I mean we just had an email chat, or X DM, and we were going to. I don't know why it didn't happen. He wanted to have a philosopher with him because we were going to talk about the nature of knowledge, and I think he was concerned I would berate him or something, which I wouldn't do. Obviously, I'd just like to explain, the vision of epistemology that comes from Popper and Deutsch, because the objectivists, the objectivism, Ayn Rand's philosophy is very different. And so I spent a lot of time delving into, as you can see in my YouTube series there about objectivism, and the objectivists are very unhappy about I think that I've completely misunderstood Rand, but I don't know how much more of it I can read, like the epistemology stuff. It's not to say that I find problems with Rand when it comes to things like economics. I even think the stuff on individualism is very good, that part of the morality. There's much that I find value, but the epistemology is just not correct. I mean, it's just not correct because of things like this law of identity that she wants to begin with, the foundation, whereas we know that what we're doing is guessing. So even if you had a law of identity, you're guessing at that. Now, you might say, well, how could it possibly be wrong? But then again, that you're just appealing to the limitations of your imagination. I can't imagine how it could be wrong. You can't imagine how it could be wrong. But, our imaginations are limited by what we are as human beings, guessing at the world, including laws of identity and so on. Aaron Martin, is a new David Deutsch episode on Topcast or Together with Naval planned? And do you know anything about David Deutsch's progress on his book Rationality? No, I don't. I guess we're all eagerly awaiting for any updates from David about what will happen with his book, his next book, his third. There's always things in the pipeline that I'm doing with Naval. And so those are coming up over the next few months. You will see some content there, I'm sure, over the next few months. Preparing for a talk in New Zealand coming up at the beginning of next week. So Topcast itself is on hold while I just prepare that. There's a lot of preparation for that thing going on and for another event that's going on as well. And so hence I'm doing this. I might do another one of these tomorrow or the next day as well. This is fun and this is easy for me to do. The regular Topcast episodes are, of course, very laborious. People have often offered over the years, I'll do some editing for you, but I'm a control freak as well. So I'll record myself talking and then I think, I didn't like that bit, and I'll do a retake. And so if I was to sit down with an editor to try and have them help me edit Topcast, the rough cut of Topcast, it'd take just as long as for me to edit it myself. So these days. Yeah, so there will be another Topcast probably in a couple of weeks. Someone's asked, did you hear of Dennis Noble's take on evolution? What did you think of it? No, I haven't. I'm afraid not. Neil Evans, how might emotional ideas be improved? Well, it depends on what you mean by an emotional idea. After all, if we begin with the stance that the contents of our minds are ideas, that our mind is just generating ideas, one kind of idea, and this goes back to ancient philosophy, are perceptions, that our perceptions are ideas, and Popper would agree with that. And so sensations, perceptions, emotions indeed are ideas. They are interpretations of something. So the emotion is an interpretation of something. You might want to call it an interpretation of a sensation. But then you say, what is a sensation? Well, that too, it's interpretations all the way down to a very large extent. So how can you improve emotion? How can you improve emotions is another way of looking at this. To certainly not be fixated, it would be one thing. If they're negative emotions, then to distract yourself in some way or to become distracted. And if they're in positive emotions, then, well, all you want is more positive emotion beyond that. And that is things like curiosity and fun and joy and all that kind of stuff. And it's a matter of finding the sources of those feelings for you. And for many people, it's in the flow state. Okay, so that's the YouTube stuff. Let me go finally to the last few things that I may have missed on YouTube, especially from Randy. I think I ignored some of Randy's things, so we'll go back and have a look. Another one about this Dennis Noble fellow. Now, I do not know. I could look him up, but I'm not going to right now. Dennis Noble's ideas about purposeful or goal-driven action of biological systems in the context of constructor theory. Given that I am a proponent of the selfish gene idea, that unless you're a system that has memes, such as a person, then this idea of goal-driven is mistaken or misleading. And even with people, it's misleading as well. People are problem-centered, and we're trying to solve our problems. And if you have a goal, I've talked about this before on live streams, I think, that the goal-driven life is a life of emotional poverty, for want of another phrase. What we should want to do is just solve our problems ever more rapidly. As for things like cells and organisms of the non-human kind being goal-driven, well, I don't know how that can mesh with evolution by natural selection, because that evolution by natural selection is about how the gene itself propagates through an environment and multiplies or fails to survive. Yeah. So I'll have to come back to that and look up this Dennis Noble fellow. But it may not seem promising if we're talking goals. Randy has also asked, do you think we should be putting more thought and effort in knowledge creation towards extending human healthy brain function? That's an easy one. Yes, of course, we should. All parts of the body to try and increase longevity, to slow the rate of decay, and better than that, reverse the rate of the human body, which includes the brain's degradation over time because of the slings and arrows of the second law of thermodynamics and whatever else. How do we find the right balance, you've asked, and prioritize the importance of avoiding loss of knowledge to death, noise versus political and cultural improvement to protect the ability to create new knowledge? It's not one or the other. Okay, we can walk and chew gum at the same time, as people say. We want to be able to foster our civilization, our society, where people can pursue their own interests, have fun while doing so, and generate wealth. Some people will be interested in, it looks like you're a neuroscientist, working on this problem of how to improve brain function, never mind the mind, brain function, how to avoid brain tumors and dementia and Alzheimer's and plaque buildups and all of that kind of stuff, how to have the synapses fire better, how to ensure the right balance of neurotransmitters, all of that stuff is your area. And more power to the neuroscientists getting involved and ensuring that our brains remain healthy. As for your next question, how do we find the right balance? I don't think we need to. No one needs that's an authoritarian answer. It's like, how do we, the collective, the government or society, dictate who should do what? How do we balance these things? Just don't ask that question. Just let everyone do what they want to do. I will let you do as much as you possibly can in helping the rest of us have healthy brains. You continue your research, you pursue that, and being a cell biologist, working on microtubules in the brain. I'm just reading your biography there on X. You should do that as much as you possibly can, and you should have lots of people helping you as much as you possibly can. And other people should find other ways of avoiding death. And as for improving political and cultural knowledge, there'll be another group of people then. We don't need to find a balance. Private enterprise can do this, but but worrying about we is when you get into this idea that government has a certain amount of money to dish out, so how should we balance this thing? Well, it's a perverse question, asking someone like me who doesn't think the government should be involved in those things to begin with, because the private sector could do so much better. So if the government stopped taxing people, they stop taxing people and taking and confiscating resources off private industry and private citizens, then those private industries and private citizens would be able to invest in the medical treatments and the research and the technology and the cultural projects and the political projects that they were interested in. And then you'd have a new golden age, a new flourishing, a new kind of enlightened way of approaching these things that didn't rest upon us all agreeing how to balance these things. No need for balance. Let some people go off and accelerate in one direction really fast, and other people just, slowly plod along. And Randy's also asked a question about constructor theory. Could the inside surface of a glass filled with water be considered a super simple, super non-specific constructor? The surface of the glass can make molecules moving towards the surface repeatedly change directions. Well, if the glass itself in this situation enables a transformation to occur, a change from one state to another, such that the glass itself is not changed, that's the constructor, then yes, it would be a very simple constructor. The way of thinking about a constructor is that entity which permits a transformation to occur while itself not being changed by the transformation, or at least allowing the transformation to proceed again and again and again. It's not destroyed or consumed like an enzyme. Kind of, that's what a constructor is. So if you've got examples of that, then yes, sure. Randy's also asked, so this will have to wait until next literal Talkcast episode where I do a proper one on the fabric of reality, because the next chapter of the fabric of reality is the time travel one. Randy's asked, if you have not done so, could you consider discussing the thought experiment about the time travel and a revolving door? I found that part of the book difficult to understand. So this is about where the time traveler steps into the time machine, which, as David explained in that chapter, better to think of as a place or a path than a device. A time machine is a place or a path, not a device. And so you can have these closed time-like curves where you step into the time machine and you step out and you're in the same place in space, but a different time. Now, if this is possible, then on Everettian quantum theory, you're in a different universe. Now, can you go back to your universe, the universe that you occupied? Well, you would be there, and so you'd have to be stepping into your own shoes, so to speak. So you'd have to move, you have to be in a slightly different place. But there are physical limitations on this that David talks about. The time machine can only send so many things back into the past before the universe fills up, or the time machine itself gets full of stuff. So the revolving door is a thought experiment, and so we will come back to that in a proper episode of Talkcast where I can actually unpack it in more detail. I think that does it take care of every single question that was asked? I think it may. Yes, wonderful. All right, everyone. We've just had one on YouTube, this is an easy one. Which of David's books do you suggest to start from for a truth-seeking person? We've only got 2, so I'll give you 3 answers. 1, The Beginning of Infinity. 2, The Fabric of Reality. 3, Flip a Coin. But more seriously, if I was starting and I knew nothing else, I'd start with The Fabric of Reality. And it depends upon what your interests are. If you're interested in science, again, The Fabric of Reality, especially if you're interested in physics, that, as I often say, that chapter 2, Shadows, was the most transformative chapter out of all of David's books, just because that happened to be filling the void in my problem situation. That provided a solution that I was looking for, and understanding our quantum theory. It made sense, and it hit me at just the right age, at just the right time, given what I was studying. But many people are not in that position. If you're not in a position where you're struggling through an undergraduate course in quantum mechanics, then your circumstance might be you want to read the beginning of infinity for whatever reason. So it depends upon what kind of truth you are. And if it's just as broad as your truth seeking, why not just enjoy the ride from page 1 of the Fabric of Reality all the way through to the final page of the beginning of infinity, reading it in order, and participating in some discussions that you can find out there on social media, X, YouTube, and watch Talkcasts. And for everyone here who's watching still, if you want to support me in this ongoing endeavor, go to www.bretthall.org and you will find ways to support me on Patreon or just donate. Thanks so much for listening. I've talked people's ears off. I know I've talked my own off. And perhaps I'll be back again in a day or two and do this again because it was fun. But until then, bye-bye now.